Hello, geometry students. Today we're going to be going over the Unit 1 review. And so go ahead and hopefully you've gone through the rest of the packet already at this point. If not, I've made a video that goes over the workbook, the Unit 1 workbook. And go ahead and do that first if you haven't already. And then as we're going through the review, everything I do, everything I write, you should be writing, okay? And also I want to emphasize that everything on the review will be on the test. So if you understand the things on the review, then the test should be not too bad. So one thing too is I want you to, if you can, pause the video and go ahead and do all the ones that you already can do. So do all the ones that you think you got already that you can do by yourself. Just go through the review, do the ones you can, and then just watch the video for the ones that you don't know. That way you're not watching the whole video unless you need the whole video. But I'm going to be going over each of the problems, and so go ahead and open up your Unit 1 packet to the review. And let me share my screen here. Again, everything I write or say, you should be writing. Okay, so right here, question 1. Does the transformation below appear to be rigid motion? So remember, rigid motion means it conserves the same shape, same size. So if this is my starting shape and this is where I end up, right? This is my pre-image and this is my image. Would that be rigid motion? Well, no, because it doesn't conserve the same shape and size, right? So this would be no. And then the reason why is because, and we can write the pre-image, is not congruent. Congruent means same size, same shape, so it's not congruent to the image. So if it's rigid, then the image and pre-image should be same size, same shape. Since this is not the case here, then we say, no, this is not rigid motion. Okay, this is not a rigid transformation. Okay, what does A, B, C, D, arrow, A prime, B prime, C prime, D prime? This means that the pre-image, so pre-image, the pre-image is always the one you start with. So pre-image A, B, C, D is transformed to get image A prime, B prime, C prime, D prime. A prime, B prime, C prime, D prime. So whenever you see those primes, those apostrophes, they're called primes, know that that'll be part of the image. Okay, so A, B, C, D is the pre-image, the starting, and then the image always has those primes on it. So when I look at this, for example, notice I've got L, M, N, O here, and then I've got L prime, M prime, and N prime, O prime. So that tells me that this is the pre-image, and then this is the image, okay? Because the image always has those primes. So we started with this one over here, and we end up with that one here. So it says list at least 2 pairs of corresponding sides. So we want to write corresponding sides. So in this case, LM is one side we can say from the pre-image, and that'll correspond to, I'm going to put congruent to, L prime, M prime. So that would be one example. They want you to write at least one more example. So another, so I basically said that this side corresponds with this side, right? So go ahead and write another one because it asks for at least 2. So go ahead and write another pair of corresponding sides from the pre-image and image. Number 4, given the pre-image below, so we're starting with this triangle, DEF, graph the image of, and then we have T, and then down here we have -5, -3. So T, this capital T, means that we're doing a translation. That means we're just shifting the object to create the image. In this case, we're shifting 5, -5, -3. The first number tells you what we're moving on the X, and the second number tells you what we're moving on the Y. Okay, so in this case, we're going to move on the X 5 to the left, right? -5. So 5 to the left and then 3 down. So for example, if I'm looking at D here, D is right here. Now I want to shift it, translate it, 5 to the left and 3 down. So from here, I go 5 to the left, 1, 2, 3, 4, 5, and 3 down, 1, 2, 3. Now I'm going to label this as D prime. Okay, D prime. Let's do the same with E and F. So E needs to move 5 to the left and 3 down. And we label it E prime. Same with F, 5 to the left, 3 down. And you guessed it, we label it as F prime. We connect those points to create the image. So this is now triangle D prime, E prime, F prime, the image. I want to also point out that these two triangles are congruent, aren't they? Because translation is a type of rigid motion. So we just shifted it over. It's still, these two triangles, the image and pre-image, are congruent in this case. Okay. Write a rule that describes the translation that maps BCDE to B prime, C prime, D prime, E prime. So starting, this is the pre-image over here, and this is the image. Okay, so we're starting over here, and I want to know, how do I move this square to end up where this square is? So it says it's a translation. So translation, that's a capital T. And then down here, we put these little, I don't know what they're called, but whatever. Little arrow things. Oh, it's not a triangle. So we're going to translate B, C, D, E, and we want to end up getting B prime, C prime, D prime, E prime. So how do we translate this square to end up where this square is? So we can just look at any point with its corresponding image point. So if I'm looking at B, I want to see, how do I translate B to get to where B prime is? Well, I would have to shift to the right. How much? 1, 2, 3, 4, 5, 6, 7 to the right. So on the X, the horizontal shift was 7. To the right is positive, and then to the left is negative. So if you ever have to shift to the left, that'll be a negative. But since we moved to the right, that's going to be a positive. Then we put the vertical shift. So from B, how much did we shift down? 1, 2, 3. So it was a downward shift of 3. So downward, that's going to be negative for the Y. Okay. And you could double check. From C to C prime should be the same. From D to D prime should be the same. From E to E prime should be the same. So all the translations should be the same from any corresponding point. Okay. A point beginning at 0, 0 undergoes the following composition of translations. Write an order pair that point for the point's final position. So we start at 0, 0, and we want to translate 3 to the right and 2 down. Then we want to translate 4 to the left and 4 down. Okay, so I'm just going to draw on one of these grids. You can draw, don't draw on, for this one, don't draw what I'm drawing, but you can use a separate grid paper. But basically, I'm going to use this one here, but don't copy it down here. Okay. So I'm going to start at 0, 0. Then I'm going to translate 3 to the right, 2 down. So 3 to the right, 1, 2, 3, 2 down. So far, this is where I'm at. And then I want to go 4 to the left, 4 down. So from here, from this new point, we want to go 4 to the left and 4 down. So where do we finally end up here? Looks like -1, comma, -6. So our point ends up at -1, -6. Okay, pretty easy. I'm going to go and erase what I put here so we have room for problem 7. Point M begins at 2, comma, -5. So we can see it here. They already put it for us. Graph and write the coordinates of R, y equals 1, M. So what does that capital R mean? Well, that means we're going to reflect across, and then the line we're reflecting across is y equals 1. So they already put the reflection line. You could see it there in the dotted line there. So we want to reflect point M across that dotted line. So remember, when we're doing a reflection, what we want to do is first we want to see how far is our point M, to the reflection line. So what's that distance to the reflection line? So if I'm starting at point M, I want to see, okay, well, how far is it to the reflection line? 1, 2, 3, 4, 5, 6, a distance of 6 away. So this distance here is 6. So that means that from the reflection line, I want to go 6 in the opposite direction to get my image. So 1, 2, 3, 4, 5, 6. Make sure you're going from the reflection line that distance. A lot of people make the mistake and go from the x-axis. Don't do that. You want to go from the reflection line to here. So this tells us where our image is. So we're going to label that as M prime. Now we want to put the coordinates for M prime. So M prime has what coordinates? Well, here we would look at what are the coordinate points from here? So it was 2. The coordinate points are 1, 2, comma, 1, 2, 3, 4, 5, 6, 7. So M prime, its final resting spot is 2, comma, 7. Okay, let's move on. Given the following triangle, graph R, y-axis, so that means we're reflecting across the y-axis, triangle DEF. So we want to reflect this triangle, DEF, across the y-axis. So in this case, my line of reflection is the y-axis. So let's go ahead and reflect our triangle across the y-axis. So for E is 3 away from the reflection line, right? See that? 3 away. 1, 2, 3. So E prime will also be 3 away. 1, 2, 3. Go ahead and label that. Put the point, label it E prime. We're going to do the same with D and F here. So D, 1, 2, 3, 4, 5, 6, 7 away. So we want to go 7 in the opposite direction. 1, 2, 3, 4, 5, 6, 7. Okay, so when point D reflects across there, it'll end up right over here. For F, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So F prime will be right here. Go ahead and connect those points to create the image. I also want to point out that these the image and the pre-image, those are congruent triangles, aren't they? They're the exact same size, exact same shape. All right, they're just pointed in different directions. So is this rigid motion? Well, yes, it is. It is rigid motion because it conserves the same size, same shape. Okay, so yes, reflections are rigid motion. Number 9, Write a reflection rule that describes figure 4. So here's figure 4. So which of these other figures is a reflection for figure 4? Well, hopefully you can see that that's figure 3 across line S. Okay. You see how figure 4, if you reflect across line S, you get figure 3. So what we would write is we can write R for reflection. And what are we reflecting across? Line S. So we write a lowercase s here. So that means we're reflecting across line S. And we're reflecting figure 3. So we're reflecting figure 3 across line S, and that gives us figure 4. Okay, hopefully that makes sense. Number 10, you're working on a design project for Moon Mirror Company. You designed the following design below, which can be described as a reflection. Draw a line and use it to write a reflection that describes how your design is a mirror image, a reflection. So what I want you to think of is, think of this M-O-O-N, moon. Think of it as a one shape. So if this is one shape, where would a line of reflection go in this shape? So where would I put a line of reflection where this shape could reflect onto itself, basically? So that would be right here. By the way, a line of reflection is also called a line of symmetry. So in this case, the line of symmetry or the line of reflection would go right here. Okay, so I want you to just describe where it goes. So for these lines here, write a couple sentences just describing where we put it. You know, you could say something like, the line of reflection goes between the two O's for this image. Okay, something like that. Next, we're going to talk about rotations. So number 11, it says use a compass and protractor to draw image of R, 90 degrees, M, triangle DEF. So what does this mean? So lowercase r, that's different than capital R. As we saw with capital R earlier, that's a reflection. But lowercase r is a rotation. So we're rotating 90 degrees, and we're rotating around point M. So in this case, point M is the center of rotation. So this is our center of rotation, and we're going to rotate this pre-image to create the image. So what you can do is I would use, if you can, and I showed you in the lesson how to use tracing paper, and you would rotate 90 degrees. So you'd trace this, you'd trace this, you'd hold your pencil there and rotate it, and you should get, hopefully you can kind of see what you would get, but you would get like a triangle down here like that. So this rotated 90, you'd end up here. So D prime would be here. E prime right here, it looks like a 90-degree angle, could go right here, and F prime would be here. Okay. Don't worry about being too precise. Here's another rotation. So again, we're rotating 90 degrees around O. So when they say O, and there's no O in the picture, what they're talking about is the origin, right? So that's 0, 0. So in this case, we're rotating around 0, 0. And we're rotating the pre-image B, C, D, E, and we're creating the image B prime, C prime, D prime, E prime. So you can imagine that if we take this shape and we're rotating it, and generally, if it says just a rotation, that's always rotating counterclockwise, okay? Unless it says it's clockwise, which usually it does not, then we're rotating counterclockwise. So if we think about where, let's look at point D. So if I rotated it counterclockwise 90 degrees, where would that end up? That would end up down here, wouldn't it? So this is where D prime is. Okay, in other words, at -1, -4. So we're for d prime, and we're going to do this for all the coordinates. For d prime, it ends up at -1, comma, -4. Okay, so notice the original point, the original d, maybe write it up here. The original coordinates for d was at -4, comma, 1. So if you remember, you could use tracing paper to trace this, rotate around this center of rotation. But you may also notice there's a certain pattern, right? Where you flip the x and y, and then whatever the y coordinate was changes signs. Yeah. But since we're starting up here in this quadrant, when you rotate it 90, it should end up in this quadrant. Okay. If you rotate it 180, it should be in the opposite quadrant. If you rotated it 270, you'll end up here. But since we're rotating 90, we're going to end up totally in this quadrant. Okay. So D moves to right here. So D ends up D prime right here. What about C? So the original point for C is at -3, comma, 5. So when we rotate it 90 degrees, where would C prime end up? Well, that would end up at -5, comma, -3. Again, flipping the x and y, and the y, what was the y coordinate changes signs. What was the x coordinate doesn't. This is only for a 90-degree rotation. 180 and 270 have their own rules. -3, comma, or sorry, -5, comma, -3. So this is where C prime ends up. Okay. Similarly, E prime, when we rotate it, is going to be at -2, -8. So let's go ahead and graph that. -2, -1, 2, 3, 4, 5, 6, 7, 8. So this is where E prime ends up. Lastly, B prime is going to end up at -6, -7. Okay. -6, 1, 2, 3, 4, 5, 6, -7. 1, 2, 3, 4, 5, 6, 7. So this is where B prime is going to be. Connect the points to create the image. Now you may notice that the preimage and image are congruent to each other, which makes sense because rotations are a type of rigid motion. So when you rotate your preimage to create your image, the two shapes should be congruent. Okay. Number 13, here they give us the preimage and the image. It's kind of hard to see, but the image is over here. You can see the dotted line. Just going to connect those so it's easier to see. So how do we go from this preimage to this image? So rotating this preimage 90 would end up here. Rotating it 180 ends up here. So if you're on the opposite side of the coordinate grid, you know that's a 180-degree rotation. So in our case, that's going to be a rotation, lowercase r, 180 degrees. And we're rotating around O, which is 0, 0. And then we would put B, C, D, E for the preimage, gives you the image. B prime, C prime, D prime, E prime. Okay. Composition of isometries. Isometries are just types of rigid motion. So composition of rigid motions. Composition means we're doing multiple of them. So there might be a reflection and another reflection, or a rotation and another rotation, or a translation then a rotation, you know. So if you recall, if we are, in this case, we're reflecting two reflections. We're reflecting across line S, then we're reflecting across line M. Yeah. Well, this one doesn't have a line name, but we're reflecting across this line and this line. And in this case, the two lines are parallel. So if we're reflecting across two parallel lines, then notice that the pre-image and the final image are kind of going in the same direction, aren't they, right? This is actually a translation. And what's that distance there? So it asks, what's the distance from point C double prime from point C? So from point C to C double prime. Okay, that's what we want to find, that distance. Now, they don't give us any numbers for distance here, but normally what we would say is whatever the distance between these two parallel lines, so whatever that distance, double that, and that gives you the distance from the pre-image to the final image. So whatever this distance is here between the parallel lines, if you double that, that'll give you the distance from here to here. So if they give you that this distance between the parallel lines is 10, then from C to C double prime would be 20. But here they don't give you that distance, do they? They just put S and T. So we'll just say it's 2 times whatever the distance between S and T is. Okay, and that's fine. Kind of a weird one. Number 15. In the following image below, line L and M intersect at point D. Okay, so we can see lines L and M, they intersect at point D, and they intersect at a 90-degree angle. So when two lines cross at a 90, we call those perpendicular. So lines L and M are perpendicular in this case. They intersect at point D to form a 90-degree angle. Okay, you can see that there. What is R sub M composition with R sub L? Meaning we are going to reflect across line M, then reflect across line L, point P. What is the center of rotation and the angle of rotation for the resulting rotation? So if you reflect across two intersecting lines, so you can see this pre-image P reflects across L, and then it reflects across M to get us, and you can see there's a P here, but it's very faint. So we reflected, then reflected again, but you could also consider that a rotation. So the amount of rotation in this case is double the angle that the intersecting lines intersect at, okay? So in this case, the rotation, so this reflection and reflection is the same as a rotation of double this angle, so that's 180 degrees, around, and the center of rotation is the intersection. So in this case, point D. So we're reflecting 180 degrees around point D. Okay. We're reflecting that P. Okay. So if we reflect and reflect, that's the same as a rotation. Whatever the angle of the intersection is, that tells you the angle of rotation needs to be double that. Okay. What is R, x equals 0, composition with T, 0, -4, triangle ABC? So we have a composition of two isometries. So we have a composition. First, we're going to do a translation. Okay. First, we're going to do a translation, and we're going to translate 0, -4. So if you recall, the first number tells you how we're going to translate horizontally, and the second number tells you how we're going to translate vertically. Now, when you do a composition, you do this right one first, okay? And then you do the left one. In most cases, it doesn't matter which order you do it, but in some cases it does. So, but you do the one closest to here, and then you work from right to left. I know it's a little bit weird, but we're going to go right to left. So the first thing we're going to do is we're going to translate 0, -4. So we're going to take our pre-image and we're going to translate 0 left and right, and then 4 down. So remember, so for each of these points, so let's look at point A to start. So 0 left and right, and then 4 down. 1, 2, 3, 4. So this is where A prime is going to be. And then B also translates down 4. 1, 2, 3, 4. Every point is going to do that same translation. Same as C. 1, 2, 3, 4. Okay. Go ahead and connect those points. Then from there, we're going to reflect across x equals 0. Now, if you see something that says x equals, that means it's a vertical line. Okay. So in this case, x equals 0. So we look at the x-axis. Where does it equal 0? Well, that's right here. So if we're reflecting across x equals 0, that's the same as this line here. So I know it's a little bit tricky, but when it says x equals 0 is the same as the y-axis. Okay, so in this case, we're going to be reflecting across x equals 0, or in other words, we're reflecting across the y-axis. So let's go ahead and do that. We're going to take this new triangle we just have, A prime, B prime, C prime, and we're going to reflect across x equals 0. So when we reflect, we want to see how far is from here. So for B prime, 1, 2, 3 away. So we want to do 3 away. So since this is B prime, what do you suppose we're going to call this? Well, this will be B prime prime. So now our image is going to have prime prime because it's now gone under 2 transformations. For A, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A prime prime. For C prime, 1, 2, 3, 4, 5, 6, 7, 8 away. So I'll go 8 away in the opposite direction. C prime prime. Go ahead and connect these points to create the image. Okay. Now I do want to point out that notice B here is on the B prime is on the right, but when you reflect it now it's on the left. So keep that in mind. But I do want to also point out that all 3 of these triangles are congruent to each other because reflections and translations always conserve size and shape. So all of these triangles are all congruent to one another. Okay. 17. If R sub t, so reflection across line T, and then a composition with translate 2 to the right and 3 up to triangle ABC gives you triangle XYZ, then list all the pairs of angles and sides with equal measures. Okay, so they don't give you a picture, and they don't even tell you where line T is. So how are we supposed to know what corresponds with what? How are we supposed to draw this? Well, we don't need to draw it at all. In fact, as long as it's a congruence transformation, meaning a rigid motion, translations, rotations, reflections, we know that the image and pre-image should be congruent to each other. Okay, so in other words, we don't even need to know what you did here. As long as we know that you didn't change the size and shape, which reflections and translations do not change size or shape, then we know the Pre-image and image will be congruent. So we know that AB, for example, will be congruent to what over here? Well, you just look at the corresponding. So in this case, AB corresponds with XY. So AB will be congruent to XY. Similarly, BC will be congruent to what? YZ. BC will be congruent to YZ. Now for line segments, right, because these represent sides of these shapes, sides of the triangles, you always put a little bar on top. That indicates it's a segment connecting 2 points. And then what's the last side for this triangle? Well, I did AB, we did BC. This would be AC, okay? Because triangle kind of goes around, right? So this would be AC will be congruent to what? XZ. Okay, hope that makes sense. Now it says we also want all the pairs of congruent angles. So in this case, angle A will be congruent to angle X. Angle B will be congruent to angle Y. And angle C will be congruent to angle Z. Okay. For angles, we put that little angle symbol in front of it. Okay. Now define define when two figures are congruent. Okay. So for this one, we already kind of know, hopefully, what congruent means. It means the two shapes or two things we're talking about, could be angles, sides, or entire shapes. They're congruent when they have the exact same size, the exact same shape. In other words, they have the same measures throughout. But the definition they're going to look for on the test, I'll go ahead and give you that here. So they want two figures. Two figures are congruent if and only if there is a sequence of one or more rigid motions that maps one figure onto the other. One figure onto the other. Okay. Now, I know we haven't talked about it like this, but the reason I'm saying it like this time is because that's the way it shows up on the test. But this is about the most confusing way to describe congruence ever. But just know that this is how it shows up on the test. But basically what it's saying is if two shapes are the exact same size, exact same shape, then in other words, they're congruent. There should always be a way to move one shape onto the other, okay, using rigid motion. So using translation or rotation or reflection, you should be able to map one figure onto the other if they're congruent. Okay, so that's basically all this saying. Now I know this is super mathy way to say it, and I know that's not very clear. They're using a lot of mathy language, but just keep in mind this is how it looks on the test. So just be aware of that. Okay. For number 19, verify SSS postulate given, and it says dt, so this length dt, is congruent to Sn, yt is congruent to En, and yd is congruent to Es. Prove that triangle YTD is congruent to triangle ENS. So basically what they're saying here is that the three sides from this triangle are congruent to the three sides of this triangle. And you can kind of see that these two triangles are congruent, aren't they? Right? The exact same size, the exact same shape, but they're just oriented in different ways. So how do we show that two shapes are congruent? Well, like we discussed in question 18, we can show that they're congruent if you can map one triangle onto the other using rigid motion. Okay, so using translation, rotation, or reflection, we should be able to move one shape onto the other to show that they're congruent. Okay, so how do we do that? Well, what I would say is we want to translate point D onto point S. Okay, now I'm using point D onto point S because I can tell that these are corresponding points, right? I can see that this angle here, where angle D is the same as this angle here. They both appear to be right angles, right? You could use Y onto E or T onto N. It doesn't matter which point, as long as you know that they're corresponding points. So we would say we're going to translate so shift over, triangle YDT until point D is on top of point S. Okay, so basically imagine I'm just picking up this triangle YDT and I'm moving it so that it's like over here, where point D would be here and then be like this. Point T would be over here and point Y would be like here. Okay, hopefully you can imagine this YDT translating so that it's point over here where point S and point D coincide. Now, if I want this triangle now, I guess I should call these with primes now because we just translated it. If I want this now to align perfectly with the other triangle, triangle ENS, what should I do here? Well, hopefully you can see you can rotate the blue triangle, triangle Y prime, D prime, T prime, and rotate it onto triangle ENS. Okay, so once we've done this translation, we want to do a rotation. So we're going to rotate triangle YDT until, and we would say maybe until the other points line up, until we could just say until the two triangles line up. Perhaps I should put rotate triangle YDT. I guess we should probably add here around or about around point S. Okay, So it's important that we're rotating around this point. So rotate triangle YDT around point S until the two triangles line up. So then once the two triangles line up, then you'd be able to, that's what we're showing. We're showing that there's a series of transformations, rigid transformations that map one triangle onto the other. Then therefore they're congruent. Okay. I'm not sure how that shows the side postulate, but there it is. On the test, it'll be basically this. Okay, for number 20, you could just go ahead and not do number 20. So this is excused. And the reason it's excused is because this link does not work anymore. This website no longer exists. Okay, so you can just put excused, maybe explain that to your teacher so that they know that this this website no longer exists, and that you could say that I just allowed you to excuse it. Okay, so, and then if they have any problems, they can feel free to email me. Okay. Well, I hope that all made sense. Hope it was clear. Hope you're able to get through the review questions with, relatively painlessly. And so again, everything on the review will be on the test. So just if you need to watch the whole video again, or just look at key ones that you're not sure about, I would suggest rewatching parts of this video to make sure you really got it down. All right. Well, with that being said, good luck on the test, and I'll see you guys next time.